In this video, we're going to take a look at the Paper 4 Abstract Data Type Study Schedule, something you can employ to save yourself a lot of time, stress, and frustration as the test pulls closer in May. Now, Paper 4 is a programming practicum, and you can program in the language that your center has chosen. Now, for Computer Science 9618, this is either going to be Java, VB.NET, or Python. For every question on Paper 4, you'll need to write a program that meets the requirements given in the description of the problem. Now, you'll have 2.5 hours to complete the exam. The better prepared you are, the more time you're actually going to have. Paper 4 assesses anything from topics 19 and 20. Now, one of the major things assessed every year is usually one abstract data type, and that can make up the majority of the exam. Because you don't know what abstract data type you're going to be asked, you need to know all of them. Well, I have went ahead and built in a study schedule that spreads it over just a couple months that allows you to get prepared way ahead of time, and that leaves you time to just review rather than learning as the test gets closer. So what are the ones we need to know, and how do we best go about getting ready for these? Well, this is from the Cambridge syllabus. So we have write algorithms to find an item in each of the following. And these are the abstract data types you need to know. So it wants you to be able to write algorithms to find an item in each of the following: a linked list and a binary tree. You got to know how to do that. You got to know how to write algorithms to insert an item or add an item into each of the following. You need to know how to add an item to a stack, a queue, a linked list, and a binary tree. You also need to know how to delete an item, a stack, a queue, and a linked list. Last year on the exam, my students were tasked with using a stack. Now, you also need to show understanding that a graph is an example of an abstract data type, but you don't have to actually code that one out. Then you have to describe the following ADTs and demonstrate how they can be implemented from appropriate built-in types or even other abstract data types: stack, queue, linked list, dictionary, and a binary tree. So then you have to be able to do recursion. So the ways this has been assessed in the past: writing a binary search recursively, implemented with a binary tree, traversing the data in a binary tree, that is done recursively. And we'll be looking at how to do more recursive procedures or programs later on this year. But you'll see here use of stacks and unwinding, when the use of recursion is beneficial. Write and trace recursive algorithms. So this could show up on paper 3, could show up on paper 4, could show up on paper 3 and 4. So let's go ahead and move on and take a look at that study schedule. Now, before we get started, having a plan is the key to being successful and not waiting. These abstract data types can be very overwhelming, but only at first. Like anything else, the more you practice, the more consistent you can be, and the better prepared you will be. This can make paper 4 a lot less stressful. Now, students before you have done it and students after you will do it, you can do this. Do not let anyone tell you that you cannot do it. It's going to be a lot easier and less overwhelming if you have a plan. Now, when we create this schedule, we're going to be looking at whole programs rather than sections like it is broken up in the syllabus. The goal of this is to become so familiar with these that in April, we are in review mode and we feel confident writing them. Now, we'll be looking at paper 4 abstract data type items to see if we are ready throughout the remainder of the school year. So make sure you're on the lookout for those videos. So let's start with queues. Queues work on the FIFO principle. That's the first in, first out principle. It's one of the easier ones and easy to code out compared to the other abstract data types. So we're going to start on December 4th. We're going to block out time from December 4th to December 10th for 20 minutes a day, with 45 minutes the first day to actually write the queue abstract data type. This doesn't mean writing on it on paper. This means actually coding it out so we have code to look at and we can actually break it down and start studying that. Now, just from December 4th to the 10th, that's 165 minutes of studying and mastering the queues. That comes out to 2 hours and 45 minutes by just spending 20 minutes a day. It's important not to be distracted while you are studying this. You have 20 minutes that you can find in your day. I guarantee it. So don't know how to code a Q? No problem. I have a video on that. You can head over to that video and check out the Q. After the Q, we're going to do stacks. That works on the FILO or the LIFO principle. First in, last out, or last in, first out. It's one of the easier ones and easy to code out compared to the other abstract data types. That's why we do Qs and stacks first. We want to build our confidence, not go into one of the complex abstract data types feeling overwhelmed. Now, we're going to do this from December 11th to December 17th for 20 minutes a day, with 45 minutes the first day to write the program for a stack. Now, again, that's 165 minutes of studying and mastering the stack. Now, that comes out to 2 hours and 45 minutes. Just by spending 20 minutes a day, with the exception of the first day, programming it out takes about 45 minutes when you're learning it the first time. This brings the total amount of time to about 5.5 hours you've spent preparing for abstract data types just by investing 20 minutes of your time a day. You have a lot of other classes. 20 minutes and you have plenty of time to master the abstract data types. All right, I have a video on stacks as well. So if you're like, well, I have a problem. I don't know how to code it. No problem. I already have a video. It's up there for you. It breaks down the code. It walks you through it step by step, covering everything that is required for you to know according to the Cambridge syllabus. Now, linked list. This one's going to take 13 days. Linked list, there are pointers everywhere in the linked list. Now, it is imperative that you know how linked lists work. That should have been covered in AS before you try to code this out. There's no point in trying to understand the code if we don't understand how a linked list works. If you're like, well, I'll just learn it as we code, I'm going to say that is not the right mindset to have. You want to know how it works so when you're looking at the code, you can start tying it back to something you know. Now, we're going to do this from December 18th to January 5th. There's going to be some empty days because those are the holidays rolling around. Now, the December 18th and December 19th, that's going to be programming a linked list. You want to allot yourself about 45 minutes per day. It shouldn't take a full hour and a half, but if it does, that's okay. If you do it all on December 18th for 45 minutes, December 19th, you wrap up with 10 minutes, that's fine. I would not recommend on the day you program trying to understand what it does. Just get the program written so you can experiment with it, see how it works, change some things. December 20th through the 22nd is going to be studying that code, working with it. December 28th through the 31st, January 2nd for January 5th, investing only 20 minutes a day. Now, December 23rd through December 27th, we're not going to do anything. If you want to use some time, like for example, say you're in the car or on a plane and you're traveling somewhere, say on December 23rd or December 27th or whatever, and you have some time and you want to look at it, feel free to do so. Now, if you study on those days, 20 minutes a day, excluding the first 2 days so we can program, this is a total of 310 minutes or 5 hours and 10 minutes, which is more than enough time to study and learn a linked list. And there's additional flex time built in for the holidays. That brings our total amount of abstract data type study time to right under 11 hours by investing only 20 minutes a day, and we haven't even hit February. We are in the early stages of January, and that brings us to our last one, the binary trees. Writing out binary trees are easy, and programming them can be too. That's up to how much time you put in. 20 minutes a day. Make sure you have a firm understanding of how these work before you try to code this out. So the dates for the binary trees are going to be January 6th to January 19th. So January 6th and January 7th, that's going to be programming the binary tree. I have a video on that as well. To traverse a binary tree, you have to do that recursively, and I have a video on how to do that. January 8th, all the way to January 19th, we're going to be reviewing the code for 20 minutes a day. That is a total of another 310 minutes or 5 hours and 10 minutes, which is more than enough time. We have reached the end of abstract data types. That brings our total amount of abstract data type study time to right under 16 hours, and we didn't even hit February. If you're trying to do all this in April, 16 hours, that's going to eat up a lot of study and review time. We haven't even hit February, and we have a schedule where we can already master these abstract data types. Now, what do we do between January 20th and the test? Well, you will now have plenty of time to focus on the other parts of the test where you feel the most uncomfortable. You want to focus on what you don't feel comfortable with so you can master that topic, then reassess, find out what you now feel most uncomfortable with, and you want to build those skills. I would recommend you spend once a week spending 20 minutes programming an abstract data type. Now remember, you only have 2.5 hours for the exam. That sounds like a lot, but it really isn't. That means you can read a problem and you can code it out, because don't forget, you got to run your code. You got to take screenshots of your code. You got to paste that into the evidence document. You also have to show the output screen to show your program working. So we want to have as much time as possible. We don't want to go into the test trying to figure out how to do things. Now, we want to go forward to the test not feeling stressed, but excited and way over prepared. Now, you can do this, and having a plan removes so much unnecessary stress. There are so many days built in for the study schedule that I just created that there is plenty of flex time. If there's a couple days you can't do it, not a problem. Just extend it a little bit. We are finishing by January 20th. That still leaves you plenty of flex time. What I would not recommend doing is say, okay, I'm going to do binary trees, and then a week later, I'll take a look at it. I would recommend you stick with it and stay focused on them. Trying to learn these the month before in April, that's going to take some long nights and a huge amount of stress. And when you have stress, you can't think clearly. Your body becomes flooded with cortisol and it clouds your judgment. We want to keep that far away. So make sure you join us as we begin preparing and covering even more topics to destroy the paper 3 and paper 4 exam. So if you found this helpful, make sure to give it a thumbs up and subscribe to help the channel grow, and we'll see you guys in the next video.